Welcome to my channel and coaching center. Today I am going to explain your 10th standard science chapter 2 acid base and salt. So let's come to the chapter. So you may know you may know acid acid or sour in taste they are acids or sour in taste, and they change the color and they change the color from blue litmus to blue litmus to red litmus. And also you may know you may know the bases or you may know that the bases are bitter in taste, and they change the color from red litmus to blue litmus paper. So what is litmus paper? It is a natural indicator which tells us whether it is acid or base. So while putting the litmus paper in acid, the color changes from blue litmus paper to red litmus paper. And means if you take a blue litmus paper, if it changes to red, then it is acid. If the color of blue litmus paper stays blue only, then it is base, like that. And some natural or turmeric is also a natural indicator. So in this chapter you will learn about more chapter you learn chapter you will learn more about acids and bases. So let's come to the next topic, that is these substance like litmus paper substance change the color and says us whether it is acid or base. It changes the color acid or base. It changes the color and says. But the ordeal other substance whose order changes other substance whose order whose order changes and changes into acid or base. This is called as olfactor in this is called as olfactor indica. It is called as. So let's know about how does the acid and base how acid and base reacts with metals. Let's know about that metal. This is a reaction in which in a delivery tube in a test tube there are some hydrogen gas bubbles and diluted sulfuric acid. Here you can see. So they are sent to a soap water, and if the bubble comes and if the candle gives pop sound. So one plus point is there to how to know whether it is acid means if we get pop sound, then we can say it as acid. We can say it as acid If we get pop sound or if there is hydrogen, then we can say it as acid when the hydrogen is passed. And if we get pop sound, then we can say it as acid. See, here hydrogen is going out, and from this delivery tube the hydrogen gas available and diluted sulfuric acid is there in this delivery, in this tube, test tube. It is going to the soap water. There the bubbles are coming, hydrogen bubbles, and the candle gives the pop sound. Then we can say it as, then it is acid, we can say, because pops. If one thing we have to remember, if any if any in any reaction, if hydrogen comes and if the it gives pop sound, then we can say it easily that it is acid. What we get here means acid when reacts with metal. Acid when react with metal, we get the salt. We get salt plus hydrogen gas. We get salt plus hydrogen gas. So this hydrochloric acid it is, and this is a metal. Zinc granule is a metal. There is another metal is there, that is zinc granule. It is metal. When this diluted sulfuric acid react with zinc granule, we get some salt, and we also get hydrogen gas. Here you can see, by that gas only we are getting that pop sound when we keep the candle in front of the hydrogen gas. Taking another reaction, to they are taking 2 NaOH plus zinc. They are taking plus zinc, they are taking, and it gives us Na2Zn2 Na2Zn2 Zn2O then 2O2 plus H2 we get, plus H2 we get, that is sodium hydrogen we get. And in this reaction we are getting hydrogen, but for hydrogen is not formed for every metal. For every metal hydrogen will not come. If we do reaction, every metal reaction occurs in metal carbonates and metal hydrocarbonates. When metal carbonates and metal hydrocarbonates react with, when they both react with acid, what reaction we get, let's know. What reaction we get, let's know. This is the reaction. So the first test tube contains Na2 CO2 plus HCl. It contains hydrochloric acid HCl plus 2 HCl it contains. So this plus 2 HCl it gives so 2 HCl it contains. 1 minute. 2 HCl it contains. So it gives N2NaCl plus H2O plus CO2. H2O plus CO2 we get H2O plus CO2 we get in first test tube you see sodium carbonate. Here in this photo, sodium carbonate and diluted hydrochloric acid reacts. So in second tube, NaHCO2 plus HCl, NaHCO2 plus HCl we get, that gives us NaCl NaCl plus H2O plus CO2. It gives us, if we add reaction, we are adding the Na2CO2, that means sodium chloride, and in second reaction here in this NaCO2 NaH we are adding hydroxide, calcium hydroxide we are adding here in second reaction. In test tube 2, here test tube we are seeing, no, and in test tube first, this test tube there are sodium carbonate and diluted hydrochloric acid, so we are getting that only. If we put CaOH plus CO2, sorry, I'm going to mute, CaOH plus CO2, that gives us CaCO2 plus CO2, CaCO2 plus H2O, that is white precipitate, means that is white color thing that is left, that we get. By seeing all this, we can say that when metal carbonate or metal carbonate, when it reacts with metal carbonate and metal hydrocarbonates, by seeing this reaction we can say metal carbonate, metal hydrocarbonate, when metal carbonate and metal hydrocarbonate reacts with acid, as we taken here acid plus acid, when it reacts with acid, so we forms, it gives us the salt, we get salt, and we get carbon dioxide and water, we get water. See here, in any reaction you see H2O water is there, and CO2 carbon dioxide is there, and acid NaCl. Here salt, that is here calcium, here NaCl, and here also NaCl, sodium chloride. So whatever you do, this you should be remembered. When a metal hydrocarbonate or metal carbonate reacts with acid, the common thing we get is, we will get one salt, we will get one carbon dioxide, and we will get one water, whatever formula they give in exam. If they ask to write metal, when metal carbonate or metal hydrocarbonate reacts with acid, take any metal carbonate in this example and do that reaction, you will get salt, carbon dioxide, and water commonly in that. We learned how the metal metal hydrocarbonate reacts with acid, and we get water, carbon dioxide, and salt. So what we get if acid and base react with each other, if acid and base both react with each other, what we get, let's know about that also. NaOH, sodium hydroxide, NaOH plus sodium hydroxide plus HCl, hydrochloric acid, HCl, reacts with each other, we get sodium hydroxide, sodium hydrochloride, NaCl plus H2O we get, plus H2O water we get. So by this we can say that when a acid, this is NaOH acid and HCl base, when acid and base reacts with each other, we get salt and water, NaCl salt and H2O water. As you all know, H2O is water. So by this I can say that acid, NaOH is acid. When acid NaOH reacts with base, and we get salt, that is sodium chloride, plus water, H2O. Now you learned how if metal hydrocarbonates or metal carbonate reacts with acid, we get water, salt, and carbon dioxide. Like that only, if acid and base, if they give an exam acid and base, you will get in that first water you will get, then you will get a salt, that is anything, maybe in what equation they have given, On that basis you will get. So next is what we get. If metal oxide reacts with acid. Metal oxide When metal oxide reacts with oxide reacts with acid, we get same salt and water only. We will get salt and plus water we will get when metal oxide react with acid. So in this common is base and when acid and base reacts with each other, we get water and salt. Like that only, when metal oxide reacts with acid, we get salt and water only. Of non-metals with base, so it is similar as reaction of acid with metals. When acid reacts with metal, like that one, it is similar. Now what is common in all acids and base? What thing is common? They may just differentiate what is common between acid and base. So acid gives hydrogen gas when reacts with metal. You all know, when reacts with metal it gives hydrogen gas. Reacts with metal, this is happened this is happened with all acids. So if we take any acid, if we react it with the metal, if we take any acid and if we react it with metal, we will get hydrogen gas only. This it happens in all acids, whichever you take acid. In this reaction you can see there is some acid and their bulb is glowing. So bulb glowing in this reaction. So there is glowing, but the glucose and HCl and this solution and the HCl solution does not produce electricity, but still bulb is glowing, glowing. This is because of acid ions present in that reaction. In that reaction, acid ions are in this test tube or in this beaker. The acid ions are produced in this beaker. Also we can put in this beaker, the acid ions are there. So acid has H plus ions. It has H plus ions at ions. Acid has H plus ions. So in this beaker, it is containing H plus ions. So we are getting the electricity. This tells us this reaction has acidic property. We can tell by this. So next topic is what happens if acid and base or in water or mixed with water solution. What will form? It is similar. Let's know about this also, as we learned about when what happens cytocarbonates when it goes with acid or base, and what happens when metal and non-metals, like that only. Now let's know about this also. Let's come to this. Let's know about the preparation of HCl takes place. So what happens means, so HCl is taken here. So there is no difference happens if H plus ions or with, there is no separation. no separation of H plus ions with the HCl molecules in water. HCl molecules, there is no separation will happen molecules in water. In this you can see there is water in that H plus ions and HCl does not happen separates. What we get means HCl plus H2O. H2O gives us H2O plus Cl. We get chlorine. Hydrogen ions is not removed. Hydrogen ions is not removed. So it should be shown. It should be shown with S plus ions. H plus ions. It should be shown in H plus ions. For example, when H plus ions react with plus it reacts with H2O. When H plus ions react with H2O, we get H3O plus. H3O plus we get, because 3 atoms here, 2 atoms of hydrogen H2 and 1 atom of hydrogen is here, so when they both combine we get H3O plus, because here plus is there, no plus ions it has. We have seen H3O or H ions or H plus ions in water. We have seen ions in water. In water we have seen that there will be H plus ions in water, hydrogen ions. So what happens means NaOH, when NaOH reacts is equal to H2O when it joins, so we get Na plus OH. We get separation of OH. We can see OH, the bases, OH plus the bases. This is the bases that are soluble in water, that can soluble in water is called as alkaline. Wait, I'll explain what is alkaline one by one. I will explain what still topics is there. When you add acid to water, it should be added slowly. And constant. There should be constant mixing or stirring should be there. Means it should be stirring, means it should be mixing, otherwise it may burn. So if you do wrong, if you put the water to concentrated acid, so it may burn or get heated, and the beaker may also burn, and the beaker or what you have taken beaker may also burn by that. So there is only process to put the acid is you have to put the acid slowly to the water, and there should be stirring. You should not keep acid water one side and keep acid one side and suddenly you should not put the water. If you done like that, it will burn or it may blast. Mixing of acid or base to water, result in decrease of concentrated ion, decrease of concentrated ions of acid and base, like acid has H plus ion, OH plus minus ions, base OH plus or minus ions, base has, like that only the concentrated ions may decrease. This is called the diffusion or called the dilution. And we also say acid is diluted. We say sometimes. Next is how strong is how strong is a acid and base solution, acid and base solution. So you all know now you learned you all know we learned that we can say whether it is acid or base, whether it is acid or base by litmus paper or other things. And what is that? I said it is natural indicator, I said. And it is natural indicator. So mixing of these all natural indicator, when of the all natural indicator mix natural indicator, then it is called as universal indicator. It is called as universal indicator, mixing or having this all the natural indicators. Let's take, we have a pH ions, we have a hydrogen ions. So calculating the hydrogen ions in a solution, so when we calculate how much hydrogen ions are there in a solution, that is called pH level of development. pH is a Posen. He is a potence. He is a German scientist. Who found this and found this potence. Potence. And potence means power. Potence means a power. It means that a power. And in pH means the full form is power of hydrogen. They call pH means power of hydrogen. pH scale has 1 to 14 numbers, and one is acidic, and till 14 is alkaline. And what happens means and 7 is neutral in that, means it is both acid and base, or it is neutral in that. 7, if we got 7 number, then it is neutral. 1 to 7 it is acidic, we can say. If we put that in any reaction, if we keep that universal indicator, and if it shows in 1 to 7 any number, then it is acidic, we can say. And it has H plus concentrated ion, and if 7 is neutral, as I said, 7 is neutral. 7 means it is neutral, both acid and base. And from 7 to 14, if we get 7 to 14, it is base, we can say that is base, if it comes in middle of 7 to 14. And OH plus ions is the molecule. OH plus is the concentrated ions for that 7 to 14, or the base concentrated ions for that. And also one minute. So see, in this photo you can see H plus ions, means that is acidic nature it is having. And OH plus ions, so OH plus ions here, it is going here, they have put it here, OH plus ions here, minus ions, sorry 1 minute, OH minus ions, I put it plus mistakenly, OH minus ions. So OH minus ions means it is base. And see here, from 1 to 7 it is acidic nature, it is having, if you use it is universal indicator, or this pH also, it is called power of hydrogen. And if you use this in any reaction, and if you get number from 1 to 7, or in any chemical if you use, if you get the number from 1 to 7, then you can say it is a acid, or it is having acidic nature. And if you get any number from 7 to 14, sorry, a number that was rubbed, 7 to 14, then you can say that this is having a basic or base, it is, or it is having a basic nature. So this is the power of hydrogen or universal indicator, which tells us whether it is like this pH, power of hydrogen, or how we can know, like this we can say that whether it is strong, weak or neutral. And still it is there, how we can say still it is very much strong or very much weak, or very equalities. I will say wait 1 minute. So I will say this in my next topic, in my next video. So till here you understand, I think so, the pH value, how the metal reacts with water, and what we get the salt and water. And when a metal reacts with acid, sorry, and when a hydrocarbonate or carbonate reacts with acid, and how to find the pH value. And keep this diagram in your mind, they may ask this diagram, this I am showing now. And how to find that whether it is a metal or non-metal by by the using the litmus paper. And many more thing I have explained it till now. So okay friends, I will explain the pH value, how to we say that whether it is weak, strong, pH value in my next class. Till then, take care and have a nice day friends. So okay friends, bye, see you, take care. I will meet you in my next video. Till then, take care and have a nice day friends. Bye friends.